In this lesson, we're going to cover the concept of services in the Linux operating system. Now, services are programs or processes that run on your servers at all times, usually from the time you boot up the server until you shut it down. These services are used to provide persistent support for requests and monitoring from other processes or from external clients. Some examples of well-known services are Apache for running a web server and Postfix for running an email server. Just like any other components of Linux, though, services can be managed as well. If you're a system administrator, you're going to be dealing with services regularly. If you're a normal desktop user, though, you may come across the need to restart or perform operations to run services as things go wrong. In this lesson, you're going to learn how to start, stop, and restart services in any Linux distribution. Now, most services are implemented in the form of daemons, which are running programs that operate in the background without the need for human intervention, which means that daemons are going to lie dormant until an event triggers them to take some kind of function or activity. Now, the init system is the first process that starts outside of the kernel, and it's generally going to be the back-end service that controls when and how other services are going to be started. The init daemon refers to a configuration file and initiates the processes that are listed in that file. This prepares your system to run the required software for you. The init daemon is going to run continuously until the system is powered off, and the programs on your system are not able to run without the init daemon. In Linux, you can initialize a system through sysvinit and systemd. The method that's going to be active on your Linux system is going to affect how you manage services on that system. For example, if you use the systemd software suite, it's going to provide for an init method for initializing the system. It's also going to provide for tools for managing services on that system that derive from the init daemon. The systemd suite was designed as a replacement for other methods like sysvinit and is now the dominant init method that's used in modern Linux distributions. The systemd suite is going to offer several improvements over older methods as well. For example, it supports parallelization, like starting programs at the same time for quicker boot up and reducing shell overhead. In systemd, control groups are also used to track processes instead of process IDs or PIDs, which provides a better isolation and categorization for all of your processes. Now, systemd is going to use unit files to determine how it's going to handle units, which are system resources that systemd can actually manage. Resources can include network services, block storage devices, peripheral devices, file systems, and many others. Daemons are going to access and manage all of these different resources for you, and unit files can also be used to set system environment variables and parameters, as well as which values are going to be passed from a parent process to a child process that it creates. By adding directives for an environment variable, you're going to be able to make it easier for a service or other unit to work with custom values as well. In systemd, targets are a method of grouping unit configuration files together, typically in order to represent specific modes of operations. Each .target file is going to be used to determine one of several ways in which the system can operate, such as running with just a command line environment, running with a graphical desktop environment, initiating a system shutdown, and many others. Therefore, you can activate a target in order to boot into a desired environment if you want to. Now, another command we need to talk about is systemctl or system control. The system control command enables you to control the systemd init daemon, and you can view running services, enable and disable services to run at boot or in the current session, and you can determine the status of these services as well as managing the system target. You can do all of this through various subcommands that are issued along with the systemctl command, including status service, which is going to be used to retrieve the current status of a given service, enable service, which is used to enable a service to be started on boot, disable service, which is going to be used to disable a service so it no longer is started up on boot, start service, which is used to activate a service immediately, stop service, which is used to deactivate a service immediately, restart service, which is used to restart a service immediately, set default target, which is used to set the default target for the system to be used on boot, isolate target, which is used to force the system to immediately change to the provided target, mask unit file, which is used to prevent the provided unit file from being enabled or activated, even when it's done manually, and daemon reload, which is used to reload the systemd init daemon, including all of the unit files. To run the system control command, type in systemctl space the options space the subcommand, space, and the arguments. The system control command has many different options you can use, including -t, unit file type, which is an option that's used to specify the unit file type to perform the operation on. The -a option is used to list all the unit files or properties regardless of their state. The -no reload option is used to prevent the reloading of configuration changes when enabling or disabling a service. The --no ask password option is used to prevent users from being asked to authenticate when they're performing privileged operations. The --runtime option is going to be used to make changes temporary. This way, they won't be present after you reboot the system. The -h remote host option is going to be used to execute the operation on a remote host that's specified by its hostname or IP address. And the --no pager option is used to prevent the output from being piped into a paging utility. There are lots of different instances when a system administrator needs to work in a GUI for a short period of time, and you can do this by using the systemctl command to change your target. Now, it's common to configure a Linux server to boot up by default to the command line environment, and you do this by using the multi-user.target file. An administrator, though, might want to switch to the graphical user environment, which is known as the graphical.target file, and we can do this for a particular task. And then we can switch the server back to the multi-user.target file when the task is complete. The system administrator would then leave the server in a more efficient command line configuration after the task is completed, which lowers the resources required to run that server instead of leaving that graphical user interface up and running. In most cases, the systemctl command is going to be used to control services, but there are some additional systemd commands that you can also use too. For example, hostnamectl will enable you to view the system's network hostname and other information about the system's hardware and the Linux kernel it's running. You can also use the command to change the system's hostname. To run this command, type hostnamectl, the options, the subcommand, and the arguments. For example, if you want to set your hostname to server01, you need to enter hostnamectl space set-hostname space server01 at the command line and then hit enter. Now earlier I mentioned systemv init, which is an older init method that has largely been replaced by systemd. However, some distributions will still support systemv init. Just like systemd, sysv init is going to provide you with various tools to manage services and the state of the system. Now, one of the major differences between systemd and systemv init is that systemv init uses run levels. They control the state of the operating system in much the same way that systemd targets are going to be used, and they're going to determine what type of daemons should be running in order to create a specific type of environment for you. In fact, the systemd targets were actually created to map the existing run levels. When we use something like run level 0, this shuts down the system. Run level 1 starts up a single user mode. Run level 2 starts up a multi-user mode without remote networking. Run level 3 starts multi-user mode with remote networking. Run level 4 is not really used. Run level 5, though, starts multi-user mode with networking and a graphical user interface capability. And run level 6 is going to reboot your system. Now, a single user mode is going to boot the operating system into an environment where the super user must log in. This means you're logging in as the root user. Networking here is disabled in single user mode, and most partitions are not going to be mounted. Typically, this is going to be used to troubleshoot issues with networking or issues that prevent you from booting into your normal multi-user environment. The tellinit command will enable you to switch to the current run level of the system. Now, on the systemd environments, the tellinit command is going to be translated into the appropriate target request for you automatically. The run level command will print the previous and current run levels of the system, each one being separated by a space. So, to use the tellinit command, simply type in TELINIT, the options, and the run level. Now, there is a special file on your system if you're using a sysv init system. This is known as the /etc/init/tab file. This is the init tab file, and it's going to store details of various processes related to your system initialization on a sysv init system. It's also going to store details of the different run levels that are in use. The init daemon is going to read from this file to determine what run level to boot into, what daemons to start, and what to do if the run level changes. Every entry inside the /etc/init tab file takes the format of ID rstate action process. The ID is just a unique identifier for that entry. The rstate defines what run levels they're going to apply to, and the action specifies one of several tasks that determine how sysvinit is going to handle the command that's defined in the process field. The /etc/init.d directory is going to store all of your initialization scripts for all of your services. These scripts control the initiation of services in a particular run level. The scripts are going to be invoked from the /etc/init tab file when the system initialization begins, using different symbolic links that are found in that file. sysvinit scripts are highly flexible and can be configured according to the needs of any given user. The /etc/rc.local file is also going to be executed at the end of the init boot process. Typically, it's going to be used to start custom services. However, this file is rarely used and is not even supported in some distributions that still use sysvinit. Now, another command we need to talk about is the check configuration command. This is spelled chkconfig. The check configuration command can be used to control services in each run level. It's also used to start or stop services during system startup. Some subcommands and options that can be used with the check configuration command to control your services include service on. This is an option which is used to enable a service to be started on boot. Another one is service off. This option is used to disable a service so it's no longer started on boot. Service reset is an option that's used to reset the status of a service. And the --level run level option is used to specify the run level in which to enable or disable a service. To use this command, simply type in chkconfig, the options, the service, and the subcommand. Now, another command we have is the service command. This is another way to control the sysvinit services through the sysvinit scripts. It's going to support various common subcommands, including service status, which is used to print the current state of a service. Service start, which is used to start a service immediately. Service stop, to stop a service immediately. Service restart, to restart a service immediately. And service reload, to reread a service's configuration files while the service remains running. To run the service command, simply type in service, the options, the service, and the subcommand.